how does the router know where to locate the operating system image? Well, for that matter, how does the router know what to do at all during the boot process? Well, we have this value known as the configuration register value. The configuration register value is in hexadecimal, and you can see the configuration register value in the output of show version. You can manipulate this to control what the router does during the boot sequence. But what I want to focus on right now is the boot field. The boot field is the very last hexadecimal character that we see here. And it is made up of 4 binary bits. So let's convert this right now into binary so we can get a better idea of what is happening. So we have 0010, 0010, 0001, 0000, and then 0010. So what we're looking at right now in this particular case is the final, the very, very final 4 binary bits, because this represents our 2, this represents our 1, this represents our 0, and this represents our 2. So it's a 16-bit number we're dealing with here that's affecting the router's behavior during the boot sequence. So if we want to control during that boot sequence which iOS image is going to be loaded or how the iOS image is going to be located, then we can control these very bottom 4 bits. So let's analyze the options that we have there. Notice that there's really only 3 different options. We have a value of 0 we can have a value of 1, or we can have any value we want from 2 through F. That's right. So 2 through F are going to accomplish the exact same goal. And notice that 2 was the default value. So remember, our hex right now is 2102 as our default configuration register value. So with a value of 2 right here, 2 through F, it doesn't matter. The result is going to be the exact same. So what is happening? We have our device looking for boot system commands in NVRAM. And these boot system commands are going to do what? They are going to describe what operating system image should be loaded and where it should be loaded from. So it's up to me as an administrator to set up these boot system commands. Now, if I don't set up the boot system commands, then we are going to default boot from flash memory. So having any value from 2 to F will automatically tell the router you're going to boot an image from flash memory. Fair enough, good. But if I have a boot system command that is located, then that overrides the flash memory and it will boot whatever I tell it to boot and wherever I tell it to boot from. Now, if you have a value of 1 there, so let's say we had 2101 instead, then in that case, we are booting the first image in flash memory. So the router essentially will just start going down through flash memory. All right, do I have an operating system image? Oh, there's one. Boom, load it right there. So even if there's 3 or 4 listed, what's the very first one it finds in that list? And it goes ahead and boots that one. And if we have a value of 0, it will force the router to boot itself into ROM monitor mode, right? It'll force itself to boot in a ROM monitor mode. So that says, don't even locate the iOS image. Just throw it into ROM monitor mode. So what are some of the other values in this case above and beyond the boot field? So we already know that the very last 4 binary bits are the boot field. But what are some of the other items we might run into in this particular case? Well, we might run into having to change a value that's going to force our router to ignore the contents of NVRAM and boot us to default factory Cisco settings. So that would be bit number 6. So let's look at this example here. I'm going to type out our original value, which was 2102, which is going to equal 0010 followed by 0001 followed by 0000 followed by 0010. All right, so what if we now manipulate the 6th bit? Well, which one of these is the 6th bit? This is where you can run into a little bit of issues. Let me tell you why. This right here is not bit 1. That is bit 0, all right? It's bit 0. So that means we have 0, 1, 2, 3, 4, 5, 6. So that is bit 6. And most people, if they started counting by 1, would think that is bit 7. Right, so you got to go from 0 to 15, and that's what we see here on the left-hand side. It says bit number 0, and the very bottom is 15. Now, some of these bits are not going to be modified at all. I don't see any bit 4 there at all, so bit 4 doesn't really matter in this case. But be mindful that you're counting from 0 to 15, not 1 to 16 when you're counting from right to left. So this is truly here bit 6. So what if we flipped bit 6 from a 0 to 1? What does that mean? It means that the system software is going to ignore the contents of NVRAM, and as a result of that, we're just going to load factory default settings, and we'll see the system configuration dialog message. So let's see what that would look like if we converted that into, we took binary and we converted it back into decimal or hexadecimal. So in this case, we would end up with 0010, 0001, 0100, and then 0010. So converting that back to hex, we'd have 2, 1, 4, 2. That's what we would end up with in hexadecimal. So by changing the value from 2102, which is the default, we convert it to 2142. And 2142 now tells the device, do not load the contents of NVRAM, load factory default settings. So when this value is all 0 here, when we have it all 0, meaning we end up with 2102, it essentially says load the contents of NVRAM. Load the contents from NVRAM. Manipulating bit 7 disables boot messages. Bit 8 is disable the break sequence, break key. Bit 9, 10, 13, 14, 15. You can read these. You can go through them. Do I want you to memorize them? No. I definitely want you to, though, to remember the boot field. Bits 0, 1, 2, and 3. So bits 0, 1, 2, and 3. And then I want you to remember what else? Bit 6, which is going to allow you to override the contents of NVRAM and boot factory default settings. Why is that? Because that's going to come in handy for password recovery. Password recovery.